You can see what was in the surface, just the steam going to the lava. Have you heard about Pele's hair? It's a thin filament of lava. Therefore, when lava is falling over an edge and the wind is blowing, you can find this kind of formation. They cool down very quickly and look like hair. And you can already find them after an eruption. And that's because they break very easily, so they turn into dust very quickly soon after the formation. There are some ice. Do you want to see what's happening if I put it on top? Yeah? So I'm going to put the ice on top. The lava is going to cool down very quickly. And when lava is cooling down very quickly, there is no time for crystal to appear inside the lava. And you're just turning the lava into what it's most made of. And it's most made of silica, 47%. So you're just turning the lava into a volcanic glass. What's happening here is some of the steam is going up, but some of it, slowly, is actually forced inside the lava and makes it glow like a balloon. So that's what you can see is just the steam trying to escape, but at the same time lava on top is getting more solid, so it's kind of trapped there. But of course, if it's too thin, you might find a west route, and everything could collapse like a souffle, kind of. That might happen actually in the front, in this area here. And then it's going down. A little bit. But you can see where I put the ice on top, it's turning black very quickly. Just turning into a volcanic glass. And behind, in the channel, you can see that the lava is not moving anymore. But inside, it's still very hot and liquid. And that's because lava is cooling down over the edge of the flow. And by doing so, it's actually insulating the lava flowing inside it. So in nature, in the open, lava is losing around 100 degrees Celsius every kilometer it's flowing. But when traveling under its own insulation, like it's doing in the channel at the moment, it's just losing 1 degree. So you can stay hot for a very long time and travel very long distance underneath. And because of that, if I go under it, I can actually lift it. Yeah, I know, I'm pretty strong. So you can see it's slightly from the edge, but inside it's still very hot and liquid. And if lava is flowing down a slope in nature, maybe the lava will be able to flow out of its own insulation. And if the lava is flowing out, it will just leave an empty tunnel behind. And that's the way to do a lava tunnel or lava tube. And here what you can see is inside it's hot, it's just way more viscous, so that's why I'm struggling a little bit to play with it. It's just because it's getting more viscous. Can you hear the lava making sound? Yeah? So that might be a bit difficult with like Mario loading the furnace in the back, but you're going to hear it later too. So this sound is just the lava cooling down. And what's happening, it's lava. When it's a liquid, it's taking more space than when it's a solid. So when cooling down, it's actually contracting on itself. But at the same time it's contracting, it's getting more solid. So it's making cracks and fissure into it. And that's what you can hear. It's just the lava breaking itself apart. And because of this cracking, especially in the pipe area over here, I'm going to put some protection on it. It's just to be completely safe. So in the next 5-10 minutes, you're going to hear a lot of sounds coming from this area. It's totally normal. And this cracking is what makes the lava feel quite dangerous a long time after an eruption is over. For example, the eruption from this summer, you could go there before. You can't really anymore because of the risk of a new eruption, but you could go there before. And that was okay. But some people were working on it. And this can be very dangerous, because first, lava can still be very hot. Depending on the amount of lava on top of each other, it can take years, and sometimes hundreds of years to cool down completely. But you could also be walking on top of a lava tunnel, and if the roof of this tunnel is not thick enough, it could just collapse. You have the cracks and fissure when cooling down. And under that, lava can be very hot, because it's a very good insulator. And that's why you have to wait a very long time after an eruption is over to be able to go in the lava safely. And I'm saying this because you could see a lot of people working on it, and sometimes the search and rescue team need to come and help them. So if you go to a newly formed lava field, that could be okay, but just stay on the path. It's not worth it to go on top, at least for a few years after the eruption. So here in front we have a bubble here. I'm going to show you it very easily. It's very, very thin. That's not the only part that got lifted. All this area got lifted too, so I should be able to go through. You can see that under that, lava is a bit more orange, because having a thin layer of lava is enough to insulate the lava flow inside it. So let's see if I can play with it a little bit. It's not so sure. It's getting very viscous. Yeah, a little bit. So you can see it's still hot inside. Let's see if I can find more. Let's see if I can play over here. So yeah, it's really viscous as you can see. It's way different than when I was doing the pellets here. But that doesn't mean it's cold. Like if I check the temperature, where I put the ice on top first, so it's dark. Now it's around 900 Fahrenheit, 480 Celsius. Still hot, but well lower than what we had at the start. But if I check inside, so in the part I just lifted here, so that was protected, it's 610 Celsius, 1125 Fahrenheit. So a little bit more. And that's because the air was protected and just cooling down slowly. And here I have a paper. Taking fire pretty quickly. And I have a tip for you to know the temperature of the lava. When lava is above 600 Celsius, 1100 Fahrenheit, that's when the lava is still emitting light. Red, orange, this kind of color. But when it's below this temperature, it's when the lava is taking a dark color. So if you see that lava is still glowing, that means it's still above 600 Celsius, 1100 Fahrenheit. It's gonna tell you like if you can touch it. Yeah, not really. But that's the only tip I got. But that shows you something. That shows that even when it's dark, like it did on the surface in some area, but it doesn't mean it's cold. It can still be hot and for a very long time. So if you're not sure about the temperature of the lava, when going to a lava field, just don't touch it. And I know it looks pretty obvious, but this summer I can tell you I saw some stuff happening and it's not so obvious for everyone. So just in case, I prefer to say it. And here on top, you can see that the lava is turning into volcanic lava. And that's because it's cooling down very fast. But if lava would have more time to cool down, we'd have time for crystal to appear inside the lava. And at the end, when the lava would be completely solidified, it would look like this here. So this red rocks around the slide, it's also basalt, but it's a crystallized basalt. But if I take this rock, put it in the furnace in the back, and melt it, you would get out the same way as you just saw. And that's because it's exactly the same composition, it's just a different speed of cooling down. And the black sand here, in the slide, well, that's what we used first to do the lava. It's also basalt, but this one exploded on Katla 100 years ago. So all three things look completely different from each other, but exactly the same composition. It's a different process of formation. Any questions so far? Like I don't see most of you, so if you have a question, just say it. And I love questions, don't hesitate. So the lava you have in front of you is not going to take years to cool down. That's because we have way less lava than what you would find during an eruption. But in the thickest part, like generally around this area, it can still take up to 3 days to cool down to room temperature. Lasts quite a long time, and we can't wait that long because we have 7 shows a day. So during the show, I start to break it. that's what I'm doing here. I start to break it. Break very easily when cooling down. And smaller pieces release the heat faster. But that's still not enough. So we just have to clean it when it's hot. We're just wearing big gloves. And with the shovel, we put all the pieces of lava back into big buckets. And we leave the buckets to cool down in the back. And generally, we use the same lava, not for the next show, but for the one after that. We have 2 batches of lava, we're just using one after another. So this lava is going to be remelted for the 4 o'clock show. And in the furnace, Mario was loading the furnace to be ready for the 2 o'clock, so the next one. We just do that all the time, just one after the other. Here I'm just going to break this one just to show you inside. It's still hot there. So it's a black layer around it where it's cooling down faster, and then it's a little spot in the middle because of the insulation. But now I broke it, it's gonna turn orange, red, and then black very quickly. I'm gonna pick up all the piece of lava later, so no worries. Okay, it's losing the color very quickly. And when you look at this volcanic glass, maybe you think about another kind of volcanic glass. Have you heard about obsidian? Or dragon glass, for the ones that remember. So obsidian is the same thing. It's a lava that cools down very quickly and turns into a volcanic glass. Except it's from a different lava. This one here is from basalt, 47% silica. When obsidian is from a lava called rhyolite, and rhyolite is between 65 to 90% silica. So way more. And the main difference is kind of the solidity. Both are very sharp. That's not a problem. This is very sharp, obsidian too. But obsidian is way stronger in a way that if you try to shape it, it's a little bit like flintstone. You can make something out of it. And that's why a lot of civilization in the past used it for tools and weapons. This one, it breaks, but quite randomly and very easily. So it's really hard to shape something out of it. It's not impossible, just way harder. But if you want to say you saw obsidian today, I'm okay with that. Almost with the same. But if you go to a lava field and take a look at the lava, so most of the time it's gonna look black, like this. But if you take a closer look, it's not gonna look glassy, like here. And that's because in nature, volcanic glass is actually very hard to do. And that's because in nature, you have way more lava. And if you have more lava, it's going to cool down slower. And if you cool down slower, you begin to crystallize. So it's not going to look like this rock. This one here will generally take centuries, and then sometimes thousands of years to cool down completely. So you find them quite deep underground. But on the surface, so the lava you can see, is still going to cool down slower than this one, because there is way more of it. So it's going to be a black rock with a few crystals in it. And that's enough to make it to not make it glassy anymore. On the surface, if you're lucky, you could see a thin layer of volcanic glass. That would be the only place lava was cooling down fast enough to make it. But does that mean we can't find a huge amount of volcanic glass in nature? Well, we can, but we just need something to cool down the lava fast enough. And this something is pretty easy. It's just water. It could be a glacier, a river, a lake, the ocean. Just need water. But without water, it's very hard to find what you just saw today. It's just like this one, it's a small amount cooled down too fast. In nature, it never cooled down as fast by itself. And to give you an idea about the amount of lava, here, well, it's on average, we have between 40 and 50 liters, 13 gallons. In the eruption in July, on the first day, the volcano was producing 40,000 liters of lava every second. 10,000 gallons every second. So of course this lava will cool down fast, which is slow enough. Let's see if I can break it. So here I can't really, destroy it very fast. Can't kick it very hard because there is a risk of pieces flying around. And I know that maybe the third row of the balcony don't really care, but maybe you have something to say. You're fine generally. I'm protecting you with my body. You're on the own there, so. So yeah, so I don't smash it very hard, but I think like right now it's enough to break it a little bit. Okay. Yes, I'll make a small piece, so I'm gonna pick it up just to show you inside. Yeah. So still very hot. Any question?
What type of metal are you using to pick this up, and is it like a conductor? Can you feel the heat?
So what kind of metal I'm using? So everything we're using here is made of steel. So bucket, shovel to clean the slide. This part here and everything I use to manipulate during the show. It's made of steel because steam is melting around 1500 Celsius, 2700 Fahrenheit. So the lava is actually not hot enough to melt it. And about the fact that it's not getting hot, so we are touching the lava, it's hot. So here you can see it was actually still very hot, but it was not completely solid. So yeah, where I'm touching the lava, it's hot. But I only leave it in the lava long enough for the heat to go all the way up. So if I would leave the rod like I'm using behind me, I will leave it in the molten lava when it's yellow. Eventually the heat will go all the way up. But if you look at what I was doing, I actually just do a few pellets here, and then I just poke it sometimes. So it's not enough to make the heat transfer go all the way. But at the end here, it's not good to touch that. So here it's not hot. It's good.
How did you guys get the lava here?
How do we get the lava here? So we have a big bucket. We go to the crater of the volcano. I would love that in reality. For the one playing Minecraft, that's basically what we do in Minecraft. So now we use this black sand. So this comes from Vik. East of Vik, there is a desert, mostly made of this. And why is that? So this actually before black sand. The real name would be tephra. So tephra is an exploded lava from the eruption. And this one comes from the eruption of Katla in 1918, like more than 100 years ago. And basically when the volcano, the lava was going in contact with the ice, it exploded. And then all this tephra, black sand, went down the mountain with a glacier flash flood that you find quite often in this kind of eruption. And then the flash flood just spread it in this flat desert, basically. And that's where we took it from. And if we use this one, it's because the lava show was pretty close by, the first one, but also because one of the great-grandfather of one of the owners was actually on the volcano in 1918. He was herding sheep, he was a farmer, and they had to run away from the glacier flash flood from the eruption. And they actually